Welcome to the National Aeronautics and Space Administration. Whether you're a new hire learning the ropes of how a space shuttle functions, or a seasoned engineer who just needs to brush up on their knowledge, this orientation film will take you through all the major steps in a space shuttle launch, from the moment it stands poised on the pad all the way to the moment the orbiter reaches the infinite vastness of space. The shuttle stack. There are three main components of the shuttle. First is the orbiter, which houses the crew and the three space shuttle main engines. Second, two solid rocket boosters, also known as SRBs, providing the majority of the liftoff thrust. Lastly, the external tank, carrying liquid hydrogen and liquid oxygen for the main engines. These components combined create a launch system that weighs shockingly over 4.5 million pounds. Launch preparation. The external tank is loaded with cryogenic propellants in the hours leading up to the launch. Launch Control does thousands of automated and manual checks to see if all systems are ready. The flight crew is strapped in, and the White Room personnel secure the hatch. Control of the countdown transfers to the onboard computers of the orbiter, the general-purpose computers. At T-minus 31 seconds, which take command of the final automated sequence. T-minus 6.6 seconds. The shuttle's three main engines fire in rapid succession. Each engine gimbals or pivots with great precision to manage forces at ignition. Engine controllers verify that chamber pressures are rising normally. The launch commits to the point of no return with confirmation that the main engines are running well. Solid rocket booster, ignition and liftoff. Solid rocket boosters ignite at T0. Hold down bolts are explosively released and the shuttle lifts free of the pad. The combined thrust from the boosters and main engines lifts the vehicle upwards with more than 7 million pounds of force. The shuttle executes a roll and pitch maneuver to align with its ascent trajectory, putting it on course towards its orbital target. During the first minute of flight, the shuttle is rapidly accelerating. As the vehicle pushes through the lower atmosphere, it approaches a region of maximum aerodynamic stress, known as max Q. The main engine throttle down to reduce the load on the structure. Once through max Q, the engines throttle back up and provide full thrust to climb to space. The solid rocket boosters burn out about 2 minutes after liftoff. Sensors detect the drop in chamber pressure, which initiates the separation sequence. Frangible bolts detonate and small separation motors fire, pushing each booster safely away from the external tank. The boosters will descend on parachutes and be recovered at sea for reuse. Second stage ascent and main engine cut off. With the boosters gone, the ascent continues on the power of the orbiter's main engines, drawing from the propellant of the external tank. As the shuttle gains altitude, the main engines throttle to maintain safe acceleration levels for the crew. At near orbital velocity, the engines throttle down for the final time. This moment is called MECO, main engine cutoff. After MECO, the external tank is jettisoned. It will re-enter Earth's atmosphere over remote ocean waters. Orbital operations begin. Once the tanks separate, the orbiter is in space but has not reached a stable orbit. To complete insertion, the orbital maneuvering system fires a pair of small rocket engines located in pods at the rear of the orbiter. These engines circularize the orbit, allowing the shuttle to begin on its on-orbit mission of deploying payloads, conducting experiments, or preparing rendezvous with other spacecraft. As for the landing, our space shuttles landed as unpowered, high-speed gliders after performing a standard deorbit burn to slow them down enough to fall out of orbit. They re-enter the atmosphere belly down using heat-resistant materials to survive extreme heating and performing S-turns to reduce speed. Once in the lower atmosphere, the shuttle flew a very steep glide slope, and the pilots took manual control to line up with the runway using a final 180-degree turn. It touches down at around 300 miles per hour. A drag chute is deployed and braked to a stop. Similarly, but not completely the same, to how a regular plane would have landed. Conclusion. The shuttle ascent is a complex and precisely controlled sequence, relying on the coordination performance of thousands of personnel, hundreds of systems, and decades of engineering. Your role in this process contributes directly to crew safety,
Nothing is worth the risk, nothing is worth the risk, nothing is worth the
and the success of every mission. We at NASA Corporate greatly appreciate your hard work and diligence. Welcome to the Space Shuttle program.